Hello everyone, thank you for attending our session today. It's really great to be here representing CenturyLink and speaking to you all about some things that we think are important to the operation of the cloud and applications based in the cloud. I want to thank AWS for partnering with us too for, I think this is the 5th year now that we've been running a lot of the telecommunications for this show and been a great partner with AWS ever since they got kicked off with their new cloud services. So I'll be speaking to you today. I'm Paul Seville. I'm our Senior Vice President of Product Management at CenturyLink, and I'll introduce Dave.
Hi everybody, I'm Dave Shakochis. I run product management for our IT solutions here. I work on Paul's team, and while Paul's going to be talking to you a lot about what we're doing to invest in cloud control and cloud infrastructure in and around the AWS cloud, I'm going to be talking a little bit about what we're doing within some of our IT solutions and managed services around how we're adapting those and evolving those to control some of those workloads in the cloud and adapt to the changing conditions that are on the network.
Great.
Far away.
Thanks. So I'm going to start off just by saying I know what you all are thinking. When you see me standing up here, you're thinking, what is this 20-year-old kid doing up here acting like he's an executive from CenturyLink? But the truth is that I'm actually old. I'm very ancient, actually. Actually, when I started in the business, we didn't even know what the internet was. We'd never even heard of the internet. When I was in engineering school, I don't know if some of you were in the same boat as me, but I remember that we used to program our mainframe computer by pushing cards into it with our program built into the cards based on punch holes. Anybody in the room here actually that old as me that you did that when you were, all right, we'll see. There's about 1% of us, so I'm sorry guys, you're in the same boat with me. But being old does have one advantage, and that is that over time you get to see things. You get to see how things evolve and change. And I am actually old enough to have seen this migration in the technology areas that we work in, moving from a centralized nature to a distributed nature. Back in the days when me and the 1%ers that are also in this room with me got started, everything was built around the mainframe. And as time moved on, we saw that whole movement flip from a centralized architecture to a very distributed architecture with a client-server model. The client-server model enabled new capabilities around, and and combined with the internet, really enabled new capabilities where laptops and PCs and e-commerce was, applications like e-commerce was much more easily deployed over that type of an architecture. And then all of us here in this room are now involved in that move toward cloud. And much of that move is happening now, and it has shifted back with cloud combined with the types of networking access have combined back to a centralized model again. But we would say, then I think that you all are also seeing that shift, that pendulum is again swinging back to a distributed model. But the question is, how far is that swing going to be? And we put up here a quote by Bob Gill. I don't know if any of you have ever met Bob from Gartner, but we totally agree with his perspective on this. That really, that what's happening now is that applications that are hosted out of the cloud, that are run out of the cloud, are going to start breaking up, and that we're really going to find that the pendulum stops swinging so dramatically between centralized and decentralized models back to one that's more somewhere in the middle, where it's really distributed across the whole spectrum, where large monolithic applications get busted up into microservices and hosted at different points in the network, in the geography, in the topography of a total solution that we need to provide for customers for cloud-based applications. Now, I don't know if any of you have ever seen a slide like this, but most, I've seen about 12 different versions of this slide, I think, and so I just picked out a few of the things that I like the most in terms of some of the applications that we're seeing and how performance of the network in combination with the amount of bandwidth consumed by applications, how those two are relating and how that's evolving. And one of the things that we're seeing, we're actually starting to see this now in some of the customer applications that we're dealing with, is that some applications are perfectly fine to host and run out of a centralized cloud location that may be in one part of the world, and it can serve very, very large geographies. But other applications that are evolving here require much tighter tolerances that are capable from that type of place to host that application. So things like retail robotics and real-time video analytics, where the response time from the edge location where that information is picked up and pushed to the application that needs to process it, and then the response that has to go back to that edge device has to be such a short amount of time that it can't be hosted centrally out of the cloud. And so we're seeing this evolve. We're seeing this evolve where different applications need to sit at different places from the core through the edge in terms of achieving the kind of performance that is needed to actually deliver it on a basis that will actually help it to perform to the spec. Now, you look at this and you go, okay, well, gee, 10 millisecond round trip delay, that's kind of outrageous. But I'm telling you, we're actually seeing this. I was with a large retailer who was looking at a retail robotics application trying to deploy it in their stores. And they're trying to host it centrally out of a cloud location, but whenever they put it out of that cloud location, the stores that were farther away from it physically, from a geographic standpoint, the latency response time from that application that was driving those retail robotics to those store locations and back was such a long period of time in terms of latency. And I mean, when I say long period, I'm talking, 50 milliseconds, 50 to 100 milliseconds. That point that application basically broke for them. And so they were looking at network configurations that tried to tie the stores together in a way that they would pick centralized stores to put the whole hardware software stack and run that application and serve stores that were geographically close to it so they could get to within the latency tolerances that they needed for that application to work and support all of those locations. Situations like that, I think, in what a lot of industry analysts are saying, are continuing to evolve and are going to become more and more pertinent to us. And that's why CenturyLink is working with AWS on different models for dealing with these scenarios, on helping with that distributed nature of a cloud solution that can support a whole range of applications, even very highly demanding applications that require high performance networking that is associated with them. So a little bit about our network, and then I'm going to hand it over to Dave just to explain why this is important. So for the CenturyLink network now, one of the things that we have found is that fiber connectivity for many of these applications is extremely important. And in a world where we're moving, 5G is rolling out, even 5G with the kind of speeds that it drives and the capabilities it drives, fiber to many of these locations, given its infinite scalability, is really desirable in helping with the performance and be able to handle some of the capacities that are needed. When you're talking about feeding, say an application that's again using retail video analytics, for example, as an example, when you're talking about taking video feeds from maybe even in large stores could be 20, 30, 40 different video feeds, pushing that up to the cloud to do real-time analytics and provide store managers and store personnel information using AI-based technology to give them real information about what's happening in their store, that is a whole lot of bandwidth that just even comes from a retail store. It's possible, though, with fiber connectivity to these locations. So from a networking standpoint, with fiber into 2,200 data centers and 130,000 enterprise locations across the world, we're positioning and we're working with cloud service providers to give them that kind of a bandwidth reach that they need. In terms of software connections, globally connected and dynamic connectivity to these end locations is becoming a reality as well. And when I say that, some of you have heard about software-defined networking and SDN technology that enables companies to actually turn up and down bandwidth on the fly to meet needs for rapidly changing situations. That kind of a scalability on demand within minutes, even seconds sometimes, to react to the situation on the ground is really important. And when you combine it with the capabilities of applications that can can harvest the power of the cloud, like AI and machine learning, you combine those two resources together, then that really is going to create some new interesting opportunities for developers to do new things that we've never been able to achieve before. Connectivity with AWS on a global basis is another key part of what we do. So I think today we reach about 22, we direct connect into around 22 of AWS's global data centers. And we think that's important because of globalization, because as enterprises want to move more and more and take advantage of the whole world as a marketplace, then they want to have that total reach. But when they get that kind of a reach to deploy their services around the world, they want to do it in a ubiquitous fashion. They want to do it in a way that's homogeneous, that it's not some kind of a different configuration, different setup for every part of the world that they want to operate in. So providing that consistent global solution and reach that combines cloud and network is an important part of this evolving strategy. Around the network services side, another important part of how the whole cloud ecosystem is evolving and how network plays a role in that is around optimization of internet performance. And these applications are often run and accessed through the public internet. The problem with the public internet, I like to say, is the tubes. A lot of people, I don't know how many internet engineers or people with internet engineering background here, but those of you that do know that while the internet is very ubiquitous across the world, the underlying connectivity between the sources of access in the internet and how it gets from one point to the cloud is not optimized at all, basically. It could run through a whole series of networks and be handed off many times between different network service providers, and that is actually can drive down performance of your applications that are hosted out of the cloud. You know, I had this one, to give you an example, we had this one customer. He actually wasn't even a customer of CenturyLink's. He was a customer of another telecom carrier, and he managed to get an email into one of our senior execs and said that this person was based in Los Angeles, was buying their internet service from another service provider. They were getting they were hosting their application out of a cloud service provider, and it just wasn't working because the performance of the network was so bad. So that person ran a tracer out through the network and found that it went from their service provider to CenturyLink before it accessed the cloud service provider where he was hosting his application. So he's saying, well, when I call my internet service provider, they say, well, call CenturyLink because, you know, if you've got a network issue, we're routing you through CenturyLink. And so when we actually looked at this, we realized that he was coming on board in Los Angeles. That carrier was routing him all of his traffic to Atlanta, where they handed it off to CenturyLink, and CenturyLink was routing his traffic up to the AWS cloud that was based up in Seattle. Okay, so this guy's jumping across the country and back again with his data stream. And he's not even a customer of ours, but he's calling us to ask us, you know, why do we have to do it, route it this way? Okay, so you know, the reason I tell you that story is that it's the actual configuration of the network, the configuration of the internet, how your applications that are running in the cloud are routing their data through the public internet is in some situations really important to the performance and success of those applications and how they do. And as a leading provider of internet services in the world, one of the largest content delivery networks in the world, we have a lot of experience around optimizing IP at the edge and helping these applications work in the cloud. And then this last piece, before I hand it off to Dave, is application control. Having that global footprint, having the ability to reach the enterprise location and provide that connectivity from one end of the world up to the cloud service provider and own that path, own the physical infrastructure that's underlying how those data bits are running through the network to reach the cloud, allows us to have great performance control over the service end-to-end across the globe and down to the millisecond and packet level of visibility. And so with that, we think we actually have some ways to explain this to you in a little bit better way, and so I'm going to hand it off to Dave.
Yep, thanks, Paul. So great. So while we've done all this investment and while we're certainly looking at managing and running the CenturyLink global network as an avenue for workloads to reach AWS, what we're also doing is talking to a lot of our customers around how they're changing their software architecture, how they're changing the way they work with their software and their business applications, and what some of the new possibilities are. And there's three big trends that we're really seeing inside of the enterprise architecture groups within a lot of the enterprises that we're working with. First off, organizations and business applications are, as many of you know, becoming a lot more event-driven. When organizations are graduating away from being very sequential and procedural and workflow driven and becoming a whole lot more event driven in the way that they design business applications, the way that they integrate between data sources. Event architectures are becoming much more prevalent throughout the enterprise architecture. And what these business events tend to do is they put a lot of stress. They can put a lot of stress on the network because a business event is only relevant for a given period of time. And there are certainly ways to, within software and within software architecture, compensate for that and eventually catch up to a business event and correlating it to a value or a corresponding trigger. But a lot of those business events dry up and they have a time-based or a time-bound source of value. So managing and being able to take event-driven architectures and manage them across the network is something that we're starting to see. Our customers ask us a lot about how the network can be used to solve some of those problems. We're also seeing is many new access patterns around data and workloads and applications. Being able to take an application or a workload and really drive the business logic, whether it's around the event stream or whether it is around a more traditional workflow application, driving those business logic triggers out closer to the data, out closer to the sources of edge control where having that trigger take effect is going to be a lot more meaningful. So access to data, moving data out closer to individual devices and sensors and moving workloads out closer to the edge of the network is something that we're seeing that are a data pattern that we're seeing and an application pattern we're seeing throughout our network, and our customers are talking to us around how they can take advantage there. And then the final area is just this whole new range of execution venues beyond just traditional cloud architectures. A lot of the applications that are being designed and either being driven out closer to the edge or event architectures that are being designed and scaled across a broad geographic footprint, they're taking place in the cloud, they're built inside the cloud, and they're being built on higher levels of abstraction. Right? We're going to hear all about this week, or a lot of the new higher levels of abstraction that AWS has been driving into their cloud. And so data services and queuing services and higher level event services and serverless architectures are starting to become the mode in which new software development is getting invested and new software development is getting catalyzed. And so these new execution venues and these higher levels of abstraction are starting to occur. And when these workloads are designed there, they want those same higher levels of abstraction, whether it's a containerized architecture or a serverless architecture, to exist throughout the core of their network. It's fine to think about an application that they want to move out closer to the edge. It's fine to think about a source of data that they want to be able to integrate into an application. But it needs to work the same way across the core of the cloud as it does throughout the middle of the network and out to the edge of the network. So that consistency is becoming something that's really important. And so we're starting to see a lot of these examples, and wanted to illustrate a couple of these examples and then give you a little bit of a demonstration around what we're doing with some of our product set and how we're combining together this idea of network control and workload awareness and workload orchestration across the hybrid cloud. So there's a whole new range of these possibilities, especially out at the device edge. Right? Here's a scenario where you can see a charging station for an electric car. Right? It's in a metro area, but this is pretty emblematic of a lot of the different device interface networks. Right? This fleet management problem that we're seeing become pretty prevalent when we're taking a look at a global network, a distributed workload, and the need to be able to run business logic out close to the edge of the network for it to have a difference. And so what that means is the need to continually push code down towards these runtime environments out at the cloud edge, push that business logic across a hybrid network out closer to a lot of devices that are going to be facing a range of different connectivity options. Sometimes it is going to be feasible to run a fiber to a pedestal like a charging station. A lot of times that charging station is going to be operating over some sort of wireless or cellular or Wi-Fi network. So being able to work across a hybrid network is going to be vital for a lot of these business problems, but then also reacting to local conditions. Right? So the right cloud with regards to workloads like this in a fleet management problem means really enabling applications and orchestrations to be able to run on some of these mini clouds and smaller hardened form factors. It's also going to mean the ability to move data sets a whole lot closer to these workloads and these execution venues. the right network really means being responsive enough to change to local conditions, right? Here's a charging station that's now blocked off because of construction, right? Does it know that? Does it know that because of sensors that are baked into the charging station? Does it know that the charging station is being used, or that it's not being used, or it's not being used for a reason? So there's a lot of different event architectures that can be strung together and business logic that can compensate for that, but the network needs to be responsive enough to know whether there's an availability issue with being able to reach that remote sensor, whether there's an availability issue with regards to being able to push code down to that environment to change the business logic in response to local conditions. And then the right network also means being resilient enough to be able to maintain connectivity to some of these production devices. And the right experts and the right expertise it takes to design these solutions together really means a network architecture and a consulting and a design function whereby you're not just looking at speeds and feeds and designing a network that goes and drives connectivity to a single venue, but you're designing an architecture that can look to all the different sources of remote connectivity and how the workloads that are going to impact that remote connectivity can be deployed. Now, if it looks like these are all sort of a similar palette, that's because they are. You can actually come to CenturyLink's booth down on the expo floor over the next couple of days. There's actually a whole VR environment that takes these are just a couple of snippets from that environment, but you can put on the VR goggles and you can actually walk around inside this world and take a look at some of these other use cases beyond the ones that I'm highlighting here. So you can take a look at some of the edge, this network and cloud convergence zone that Paul was highlighting there on the second slide, and really look at some of how these workloads piece together. Now, here's another example, and this is one we face a lot. It's a little bit more traditional, where we're looking at a little bit more of a traditional enterprise business location like this coffee shop in a mixed-use facility. Right? This is where business workloads and business applications are being pushed down, whether it's to monitor internal store transactions or inventory control, like the example Paul was talking about there, across a major retail location. But one of the more important pieces of business logic that tends to happen out here at the edge is the data minimization function. Right? You can collect everything. You can collect everything and send everything back to the public cloud, but should you? In most cases, the answer is no. Right? In most cases, what you want to be able to do is collect the data and only send back for long-term archival and long-term analysis what you really need. Right? You don't want to be sending a whole lot of errata from every single device or every single sensor that's inside the facility. So pushing business logic out that can go and update and drive that data minimization function is important. And so the right cloud really means enabling this hybrid cloud application where it either needs to be able to run on a workload inside the store boundary or inside a specific geographic boundary or within a particular latency zone. But it also means pushing as many of the corresponding workloads up to the public cloud like AWS for longer-term analysis and longer-term development and testing of business logic that will run inside these environments. The right network means a more traditional hybrid connectivity where locally sourced broadband and locally sourced fiber links are going to combine together to be able to give access back to those computing centers. But it also means forms of digital connectivity that can be spun up on demand. And a lot of what Paul talked about with regards to our software control, about being able to take a brand new store and dynamically create a high-speed Ethernet connection back to AWS into one of the different peering centers with AWS is really important, especially in these retail kind of use cases. And the right expertise is really around taking a managed services approach to piece the entire network together, and including broadband aggregation and being able to run in some of these distributed locational environments, being able to run the project management function, bring the devices on net, and also design what are going to be the critical workload execution functions that this particular location is going to rely on. It also means taking into effect some of the location-based analytics and taking a look at who's using that particular network inside that store and how we can generate new sources of business logic in terms of people who are using your local Wi-Fi, individual custom offers that you can drive into that retail location, and things like that. Those all have a time-based dynamic to them. And the final piece here, and this is represented a little bit outside of our VR environment, but it's to illustrate this idea of these new possibilities in edge computing, especially in metro areas and deep edge locations where we're starting to see the need for emerging computing locations and workload execution venues running inside the core of the network, satisfying some of these low latency, high bandwidth application requirements, whereby today you're starting to see this in terms of caching architectures, network function and application function service value adds running inside the core of the network. But what we see happening long term and what the right cloud needs over time is enabling hybrid cloud to be able to take cloud spanning applications that run a combination of workloads across the global cloud core all the way through the network out to the global cloud edge with that layer of consistency for not only running the workload, but running the workload with the data and the service abstractions that are developed around that workload inside the global cloud core and maintaining that consistency out to the edge. The rate network means being able to take this type of computing and syncing it up with being able to drive a series of choices for the application architect to think about the data center differently and to start to think about the network as a data center. The network is the data center starts to become the mindset that we have a lot of our professional services and the CenturyLink managed services architects starting to think about. And so that's where that expertise really comes in. So you can feel free to come by the booth and explore a lot more of these workloads, but what we thought we would do here is move into a little bit of demo mode and show you how those workloads and how some of the value-added services that we're building around our network can help you highlight that. So we have a really simple example workload or an example scenario that we're going to drop in, and it really highlights this idea. So what we have is a business workload. It's just going to be a really simple product intranet type of collaboration application, really super simple, but we're going to be comparing that application performance, and we're going to be generating load on that application from an environment that has a specific distance latency and a distance characteristic. So 2,000 miles away, we have an audience for this particular workload. It's an audience of workers that we're going to simulate up in the Pacific Northwest in Seattle. We're going to deploy that workload to AWS US East 2, and we're going to deploy it in a couple of different network configurations. So we're deploying that workload, and we're orchestrating it, and we're also controlling how the network reaches that workload in a couple of different scenarios. And so there's one path that it's going to follow, which is just going to bounce around the internet at best effort. Right? It's going to move through the internet, obviously a very high throughput, high transaction, very resilient type of network, but it's going to make its way through that network, and it's going to land up in the US East 2. But we're also going to be using CenturyLink's Cloud Connect Ethernet network to design an express path, right? A straight shot through from the office out to US East 2 to really streamline that connectivity. What we're going to do as sort of the measuring stick and sort of the tail of the tape between those is we're going to simulate the CenturyLink managed services and some of our network architecture consulting teams who would come in and help a customer make a workload decision based on how we're deploying the workload to the public side, how we're deploying it across the private side, making sure it's an apples-to-apples comparison so we can start isolating what the differences are between the way that workload works under one network condition versus the way that it works under a different network condition. So a really simple type of exercise. So first we're going to show you how we do it, and then we're going to show you a little bit about what the tail of the tape looks like in between these two scenarios that we have up and running. So we'll do a quick prayer to the demo gods, and we will switch over to the CenturyLink Cloud Application Manager environment. So we have a service we call Cloud Application Manager. This is a service that is CenturyLink's view around how to take the breadth of our network, be able to add value-added services on top of it, and really help drive collaboration between the three spheres of influence inside of enterprise IT, which is fundamentally IT finance, the development community, and then the operations group within those organizations. And so we'll start off and take a little bit of a look about how Cloud Application Manager can be used to help the IT finance organization. So all customers of CenturyLink Cloud Application Manager can be organized as, I can blow it up here a little bit, as organizations. That's sort of our nomenclature for a company. A cost center, which is an internal nomenclature for how you're going to be organizing and managing costs. And then an individual workspace. A workspace is an area in which a development group, an application owner, a product team is going to be working on a particular project or an environment. An admin of a particular organization can go in and they can really have a deep level of control about how they drive. It's obviously designed to work across the hybrid cloud, but for organizations that have gone all in on AWS, that's really easy to set up and enforce by policy. You can roll through, and in this particular organization, this is called Parts Unlimited. Everybody read the Phoenix Project, the old Phoenix Project Agile DevOps book. Yep. So we're simulating that particular company. When they've decided to go all in on AWS, and they're going on down, they can decide of the myriad different downstream cloud platforms that Cloud Application Manager can interact with, they can just check off all the ones that aren't really rated as worthwhile of their enterprise architecture deployment patterns. Right? So they can uncheck all the other clouds and basically keep it to their private in-house data center as well as AWS. So that's all completely configurable. Once they have that up and running, they can then run a series of reports to understand per cost center, per cloud provider, per environment, how they are taking advantage of that. There's a whole bunch of deep analytics that IT finance can take advantage of. Once the IT finance organization has set up the organization and organized things into cost centers and workspaces, and they're helping to administer and drive and run the innovation pipeline for the organization, the development group can use Cloud Application Manager as a really lightweight development and deployment tool. Right? So it's a lightweight envelope you can use for a range of different configuration management and application deployment constructs, and it basically has three primitives: the provider, the box, and the instance. A provider is basically a downstream deployment environment like AWS US East 2 or AWS US East 1 or any one of the AWS deployment zones. But a private cloud or a local data center could also be a provider. A box is just an application model. It's a model of a known good state. An instance is a combination of the prior two. So a box deployed to a provider becomes an instance. And so those instances can be set up and deployed. New providers can be set up and deployed here. As you can see in this particular example, we could go start up and try to create a new provider, and all that's available to us is AWS and some of the in-house VMware-based private clouds that this environment has available to it. The boxes can be set up and deployed. In this particular case, we have a product intranet box, which we have that is demo deployable. We're going to go and take one of these, and we're going to create a new instance of that box. And we're going to take it, we're going to search it on down and find the product intranet box. We're going to deploy that product intranet box to a deployment policy in US East 2, which we call our AWS production secondary. And we can go and kick that off and deploy it. We can put an expiration date on that box so that Cloud Application Manager will automatically go in and harvest it. So this going out, it's reserving resources, it's designing that box deployment model, and it's getting ready to kick it off. We've already got that done, and we have a number of those instances already up and running. So we have a few already there. We have a private route and a public route for the product intranet in true cooking show fashion. We already have a couple of those set up and running. Well, those two that are now set up and running, what we can also do is turn this workload over to operations and have our operations team also keep an eye on it, integrating through Cloud Application Manager and a lot of their in-house tool set. So it integrates with the CMDB for ServiceNow, or it can be fully managed and run by CenturyLink's in-house managed services organization, and so we integrate it in with our BMC-based event management system. But customers can also take advantage of some of the tools we've built around this. Again, it's an MSP-certified offering, meaning that we've gone and done some of the next generation management and predictive analytics around operational workflows. This is in particular the US East instance that's already been deployed. And we can get in there and take a look at some of the different metrics and do and edit some of the forecasting. So we can look for and design forecasting algorithms and say, let us know based on the previous 12 hours what the next 12 hours is going to look like. We can start doing some anomaly detection in terms of some of the core monitoring and metrics. And these can either be responded to by CenturyLink on a managed services perspective, or they can be responded to by an environment that the customer manages on their own. So the final piece that we want to dig into here is, we're going to have to jump into it because it timed out on me. We can jump into the network control environment. So we can go in, and within that workspace, we can say, now that we have those workloads created, we can go and create a layer 3 multi-point exchange whereby we're designing that private network link. So this is the demo that we have for our Cloud Connect environment. We'll zoom in here a little bit. We can see that we've created a multi-point layer 3 connection between 3 different environments. We have one where we're running our private cloud, where sort of the in-house back office data center environment. We have an environment that is the Seattle office. And then we also have an environment that is AWS US East 2, and that's where these 2 production workloads are going to be deployed to. We have one of those environments that's set up, and that will be the path by which we go and take the Seattle office and generate that private network connectivity, which we can see on the global map is the connectivity that we've designed with this Cloud Connect interconnectivity. So we've gone and deployed our workloads. We've got them both running up in US East 2 in basically the same tenancy. We've gone and designed and optimized the network path to be able to reach one of those instances, and now we need to take a look at the tail of the tape. So, what happened and what's the difference? And this is really where our managed services and our consulting team would come in. So what we have here is, this is just a remote desktop into the Seattle environment. So we're actually sitting there simulating what would be the desktop in Seattle that's going in and working with those workloads. And again, a really simple workload. It's a simple WordPress site, and we're hitting this every few minutes and we're reloading it. This in particular screen that's refreshing right now is the workload that's sitting there over the private network path. So what our managed services and our consulting team would typically do is go in and deploy the Dynatrace as a partner. They're exhibiting here at AWS. They're a great partner of our managed services and our consulting groups to be able to really take in, and what they're really great at doing is drilling down individual transactions into their component pieces. How long is an application transaction waiting on network or an aggregation of network-related time? And network isn't just pure bandwidth. It isn't just pure router-to-router latency. DNS lookups and redirects and all sorts of network wait time contribute to application perceived outcomes that are attributable to network. They can go and then break that down into a number of different components to really create what is an ongoing metrics-based view of what average wait time and average user experience is looking like. And so what we have here are a couple of tabs. We have a tab that's representing, this is the application running over the private path. We have another tab open inside Dynatrace looking at the last 2 hours of that application that's gone over to the public path. And so what jumps out at you when you hover over it here on the public path, maybe a little hard to see, but the final number in that pop-up box shows that the network consumption time, averaging out just north of 200 milliseconds. So again, that's not just pure latency, right? It doesn't take 200 milliseconds of round trip to go from Seattle to US East 2 and back, but all of the applications that are attributable to network, including latency, add up to about just north of 200 milliseconds. And the overall average time, the average load time for that application, for the user action duration, or what seems like a visually complete, is just north of 700 milliseconds. So the visually complete time is just north of 700. Attributable to network within that is just around 200 milliseconds. When we're going over the private path, and this is going to a workload that is running over that private direct Ethernet connection between Seattle and US East 2, what we're seeing is a much more compressed set of contributing factors. And so if you look at the last number there in the pop-up metric, it's right around 50 to 60 milliseconds, just north of 60 milliseconds on average, that we see attributable to network time inside of that workflow. The overall visually complete metric is hovering just around 140, 135, 145 or so milliseconds of visually complete time. So Dynatrace helps us do that. Dynatrace helps us take a series of application transactions, break them down into their component parts, and measure them out, and then helps us start to make decisions. This one might be a pretty obvious one, but in all these scenarios, two things are true. One, there's a lot of contributing factors to what makes good application performance. It's not just network. There's a lot of things that factor into it in terms of application configuration, how the network routes, what services are being relied upon over network, as a lot of us who work in the application development space know and understand. But having this level of visibility and being able to couple together workload orchestration with control over the network gives you so many more options. Right? From here, we can start working with our customers to make a number of different options. Maybe it's just as simple as driving this workload over a private network path, because while these visually, these aren't that significant, we're talking about a few hundred milliseconds, they add up, especially when those workloads and those transactions are really starting to pile up over time. So it's a huge benefit when these things are done at scale, and our application architecture teams and our managed services group work with customers to help make those decisions. And then increasingly, we can start to take a look at the overall design of the network and the overall design of where workloads ought to run, which particular geography and which particular availability zone those environments need to run in, and how we're going to design a network to connect those together, and then decide what level of management, ongoing orchestration, ongoing reporting we can help that customer with to drive some consistent governance, so that as new innovation initiatives kick off, they're falling into the same network deployment patterns, they're falling into the same security and governance deployment patterns, and they're being architected and deployed and modeled in a consistent way. So we can click on back out of the demo and then sort of wrap up. So yeah, with that, in conclusion, I think we saw the difference between running this over the private network link versus over the public internet. And that's really what CenturyLink and really what our partnership with AWS is all about, is making sure that we're driving the right connections to customer enterprise networks and how those networks will evolve over time. We're driving connections to the different parts of AWS and how AWS is evolving over time with new availability zones and new features and new deployment models within the AWS cloud. And then we're also thinking about new connections to a new way of managed services that is inclusive of both managing the workload, deploying and monitoring and operating that environment, but driving collaboration between IT finance, the development organization, and the operations organization, while also including in the orchestration and control over network connectivity as a critical part of that triad and a part of those three spheres of influence inside of enterprise IT. And that's really what we think about when we talk about redefining connectivity. So we're deploying, you can come on by the CenturyLink booth, take a look at what some of those other next generation customer success stories and scenarios that are going on inside of the VR environment that we have inside the booth. We'd love to answer any questions you have there, but until then, we'd be happy to take any questions that you guys have around what CenturyLink is working on and how we're helping customers inside the AWS cloud. Question in the back. Yeah, what you're touching on there is really something that is one of the soft problems inside of IT leadership today, right? Which is driving collaboration between teams. You can lay it out there and sort of dictate a tool strategy, but then that starts to constrain and starts to restrict what your teams are able to do. And so what we really do with our approach is strive for a very lightweight model that allows the customers to still use the underpinning platforms for what they're designed to be used for. You don't want to constrain organizations and constrain developers and creatives for being able to design workloads and solve business problems with the maximally efficient tools that are available to them, but you do want to keep a high level of governance and orchestration across things. So are they connected to the right network, or are they just routing things over the internet? Are they tunneling things with inconsistent credentials? Are they connecting things and deploying application patterns and deploying software patches in an inconsistent way? So we really think the answer there is to give a high degrees of freedom, but with enough of a governing scaffold to be able to drive some consistency and let the teams move as fast as they can. But yeah, there's a lot of moving pieces there, and that's why we really focus on network, IT finance, and then the development and operations groups.
Yeah, and I would add to that, David, that one of the things that we are saying, that we are seeing when we're working with the cloud service providers, is that the tie to you can't just be thinking about, I'm going to run an application, and wherever that application needs to be supported, whatever locations need to be supported, it's just going to work over the existing network infrastructure, over the public internet. The cloud service providers know that. And that's why they're actually working with us really closely to try to optimize all types of network connectivity from enterprise locations back to their cloud, where their major cloud data centers are. The public internet itself, working with them on creating optimized IP routes that put them on kind of a faster track with so that they don't have to go through as many hops in the network to achieve that performance that they need there. From layer 2 connectivity that maps a dedicated customer circuit from that location through the fastest path possible through the network with as few hops as possible to get directly to where that cloud data center is at. And the multiple ways that we could bring in network into the cloud service provider data centers is really all part of that solution that as an industry we've got still a lot more maturing to go to before we reach the point where applications can reside pretty much anywhere without having to worry about where the network is. Some applications are totally cool with really long latency performance times or some random packet loss on the network. It doesn't cause them problems. But other ones, when you're needing to work with create high performance applications, that's where you got to start thinking about all those parts together, and that underpinning infrastructure is a complicated part of that solution.
Okay. I don't see any other hands up, so happy to stay up here and chat with anybody who wants to come on up afterwards. Thanks for your time, and I hope everybody has a great reInvent.